All right, so welcome to the deep dive. Today we're going to be taking a deep dive into data science and big data.
Very exciting.
I know. I feel like everyone's talking about these things, but I think, sometimes it feels like they're speaking a completely different language, so.
Yeah, it's definitely a buzzword-heavy area.
Exactly. So we're going to try to unpack some of that today, and we're going to be using two sources.
Yeah.
Katie Nugget's article called Data Science and Big Data Explained, and also a study portals page about master's degrees in data science and big data.
Sounds good.
Yeah. So those are kind of our jumping off points. And I like that they're kind of from different angles. One's more technical and one's more educational. So I think that'll be good.
Yeah, that'll give us a more well-rounded view for sure.
So I guess first things first, what is data science? I feel like I hear it all the time.
It's everywhere.
And even in the Katie Nuggets article, they talk about if it's even a new field or just like rebranding of existing practices. So
Right, yeah. I think it's, it's definitely drawing on things that have existed for a long time, like statistics and computer science, but it's bringing those things together in new ways and applying them to this new world of like massive data sets.
Okay, so it's kind of like a fusion.
Yeah, like a fusion. Yeah.
Of all these different disciplines.
Exactly.
Yeah.
Focusing on, like you said, this massive amount of data that we have now.
Right. So that brings us to the big data part of it.
Yes.
Which I feel like people throw around and it just means like, oh, it's just a lot of data.
It's a little more than that, yeah.
The Katie Nuggets article talks about this 3Vs model.
Yes.
Volume, variety, and velocity.
That's right.
What does all that mean?
So volume is pretty straightforward.
Yeah.
Just the sheer amount of data that we're dealing with, which is, truly astronomical at this point.
Yeah.
Variety refers to all the different types of data that's out there. It's not just numbers in a spreadsheet anymore, right? We have text, we have images, we have audio, video, sensor data, social media posts. It's just this huge mix of everything.
Oh, wow. Yeah.
And then velocity refers to the speed at which data is being generated and the speed at which we need to process it. Like, we're getting a constant stream of new data all the time.
So it's not just the quantity of data, but also like the different formats it comes in and then how fast
exactly.
it's coming at us.
And that makes it much more challenging to manage and analyze. Yeah.
And so how does data science tackle that? How do they deal with all that?
Well, data science provides the tools and the techniques and the frameworks for making sense of all of this data, for extracting valuable insights from it.
Because Katie Nuggets kind of compares data to gold.
Yeah, it's valuable, but it's not valuable in its raw form, right?
Right. So what is that goal? What are we looking for in all of this data?
We're looking for insights that can help us understand the world better, make better decisions, solve complex problems.
Okay, yeah.
Think about things like personalized recommendations that you get on Spotify or Netflix or Amazon. That's all powered by data science, right? They're analyzing your past behavior to try to predict what you might like in the future.
Mm-hmm.
Or think about medical research. There's huge breakthroughs happening in medicine right now, thanks to the ability to analyze massive data sets of patient information.
Wow.
And that's helping doctors to, diagnose diseases earlier, develop more effective treatments, and so on.
Yeah, and that's something that Study Portals talks about too, right? It's like this career is blowing up because of how much data.
Absolutely, yeah. The demand for data scientists and related professionals is skyrocketing right now.
Yeah.
And Study Portals is talking about, the kinds of skills and knowledge you need to succeed in this field.
Yeah, they get into some of the specifics, which I think we can talk about later. But I mean, it sounds like this is a really valuable skill set to have no matter what.
Absolutely. Even if you're not going to be a data scientist per se, just having a basic understanding of data and how it can be used can be hugely beneficial in almost any career.
Yeah.
Because we're living in a world that is increasingly data-driven.
Right. And even just being able to read a chart or understand what a statistic means or, being able to look at data and be like, wait, this doesn't seem right.
That's right.
That's a really important skill.
Having that critical thinking around data is becoming more and more important for everyone.
Okay, so we've talked about data science. We've talked about big data. What's the next step in our deep dive? What are we going to cover next?
Well, let's talk about the different types of data that we encounter, because not all data is created equal.
Okay. All right. I'm intrigued. Tell me more.
So, the Katie Nuggets article talks about structured data, unstructured data, and then semi-structured data.
Okay, I'm listening.
So structured data is the kind of data that's very neatly organized. It fits nicely into rows and columns in a spreadsheet or a database. Think of things like sales records or financial transactions. It's easy to search, it's easy to analyze. Unstructured data is kind of the wild west of data. right? It's messy. It doesn't fit neatly into categories. Think of things like text documents, audio files, video footage. It's valuable, but it's much harder to work with.
Yeah.
And then semi-structured data kind of falls somewhere in between. It has some structure to it,
Right.
but not as rigid as structured data. Think of things like social media posts or emails. They have some elements that are structured, like the sender and the recipient, but the content itself is unstructured.
Okay, so I guess it's like a spectrum.
Yeah, exactly. It's a spectrum.
Yeah.
And the way we approach analyzing these different types of data is going to be different.
Yeah, that makes sense.
So you need different tools and techniques.
Okay, so we've got our structured data, which is like neatly organized in rows and columns. Our unstructured data, which is like a jumbled mess.
Yeah, like a jumbled mess.
And then in between is semi-structured, where it's like, well, it kind of has some organization, but not really.
Yeah, exactly.
Okay, cool.
And understanding those distinctions is key for choosing the right tools and approaches for analysis.
All right, so where do we go from here?
Well, now that we have a better understanding of the different types of data, we can start talking about how to actually make sense of it all. Data analysis.
All right, perfect. Let's do it.
So how do we make sense of all this data? I mean, the Katie Nuggets article mentions all these different approaches, like descriptive statistics and inferential statistics, and then data mining and visualization.
Yeah, it's a lot. Can you break some of that down for us?
Of course. So let's start with statistics. Descriptive statistics is all about summarizing and describing the main features of a data set. Like if you have a bunch of numbers, you can calculate the average, the median, the range, things like that, just to get a sense of what the data looks like.
Okay, so it's like getting a quick snapshot of the data.
Exactly. And then inferential statistics is a bit more complex. It's about using a sample of data to make inferences about a larger population. So you might take a survey of 1,000 people and then use that data to try to draw conclusions about the entire country.
So you're kind of like extrapolating from a smaller group to a larger group.
That's right. And that's where things like hypothesis testing and confidence intervals come in to make sure that our inferences are statistically sound.
Interesting. So that's statistics. What about data mining? What does that involve?
Data mining is all about digging deep into data to find hidden patterns and relationships. It often involves using algorithms and machine learning techniques to sift through massive amounts of data and uncover insights that wouldn't be visible to the naked eye.
So it's like being a data detective looking for clues.
Yeah, exactly. You're looking for those aha moments, those hidden gems of knowledge that can give you a competitive advantage or help you solve a problem.
And then there's visualization. What's the role of visualization in data science?
Visualization is all about taking data and turning it into something that we can see and understand more easily, like a chart or a graph or a map. It helps us to identify trends and patterns and to communicate those insights to others in a way that's clear and engaging.
So it's like taking those data insights and making them come alive.
Yeah. It's about storytelling with data, really. Yeah. And good visualizations can be incredibly powerful for persuading people, for making a point, for driving action.
Now, the study portals page talks about all the different career paths in these fields, and they mention specific job titles like statistician, data analyst, quantitative analyst.
Yeah, there are so many different roles within data science, and each one requires a slightly different skill set.
Can you give us a little breakdown of what those roles involve? Like, what does a statistician do versus a data analyst?
Sure. So a statistician is someone who is deeply knowledgeable about statistical methods and how to apply them to real-world problems. They might be involved in designing experiments, collecting data, analyzing data, and interpreting results. They're the ones who can tell you if a trend is statistically significant or just random noise.
Okay, so they're the experts in statistics.
Yeah, and then a data analyst is more focused on working with data on a day-to-day basis. They might be cleaning data, transforming data, building dashboards, creating reports, and so on. They're the ones who are making sure that the data is accurate and accessible and ready to be analyzed.
So they're kind of like the data wranglers?
Exactly. They're getting the data into shape so that the statisticians can do their magic.
And what about quantitative analysts? What do they do?
Quantitative analysts, or quants as they're often called, tend to work in finance. They use mathematical and statistical models to analyze financial data, to assess risk, and to make investment decisions. They're the ones who are building algorithms to trade stocks or to manage portfolios.
So they're the ones who are trying to beat the market.
Yeah, that's a big part of it. They're looking for patterns and signals in financial data that can give them an edge.
It sounds like all of these roles require a strong foundation in math and statistics.
Definitely. But it's not just about the technical skills. Communication is also really important. Being able to explain your findings to others, to tell a story with data, That's crucial for any data science role.
Yeah, because what good is an amazing insight if you can't communicate it to anyone?
That's right. Data storytelling is becoming a really important skill in this field.
So we've talked about statistics, we've talked about data mining, we've talked about visualization, we've talked about career paths. Is there anything else we need to cover in this deep dive into data science and big data?
We could talk a bit about the tools of the trade, the software, and the technologies that data scientists use on a daily basis.
Okay, yeah, I was kind of wondering about that. What are some of the most popular tools out there?
There are tons of different tools, and the landscape is always changing. But some of the most popular programming languages for data science include Python and R. They're both open source, which means they're free to use, and they have huge communities of users and developers, which means there's tons of support available.
So if you're just getting started with data science, Python and R are good places to start.
Yeah, definitely. And then there are a bunch of different software packages and libraries that are built on top of these languages, like Pandas for data manipulation, scikit-learn for machine learning, and matplotlib and Seaborn for data visualization.
Wow, it sounds like there's a whole ecosystem of tools out there.
There really is. And the great thing is that most of these tools are open source and freely available, which means that anyone can learn data science and start experimenting with it without having to spend a lot of money.
That's great. It makes data science a lot more accessible.
Absolutely. And then, of course, there are also commercial data science platforms and tools available, which can be more powerful and scalable, but they also come with a price tag.
So it depends on your needs and your budget.
Exactly. But the important thing is that there are tools available for everyone, whether you're just starting out or you're a seasoned data scientist.
Now, the Katie Nuggets article mentions different types of databases like relational databases and NoSQL databases and NewSQL databases.
Yeah, databases are essential for storing and managing data, especially when you're dealing with large volumes of data.
Can you explain the difference between these different types of databases? It all sounds a bit technical to me.
I know, it can be a bit confusing. So relational databases have been around for a long time. They're very structured, and they're good for storing data that fits neatly into tables, like customer information or financial transactions.
Okay, so that's like the classic spreadsheet style database.
Yeah, exactly. And they use something called SQL, structured query language, to query and manipulate the data.
SQL. Got it.
Now, NoSQL databases are newer, and they're more flexible. They're designed to handle unstructured data or data that doesn't fit neatly into tables. They're good for things like social media posts, sensor data, or log files.
So they can handle those messier types of data that we talked about earlier.
Exactly. And then NewSQL databases are kind of a hybrid. They try to combine the best of both worlds, the structure and consistency of relational databases with the flexibility and scalability of NoSQL databases.
So they're like the best of both worlds.
Yeah, that's the idea. But choosing the right database for your needs can be a tricky decision. It depends on the type of data you're working with, the volume of data, the performance requirements, and so on.
So it's important to have a good understanding of the different options before you make a decision.
Absolutely. And there are lots of resources available to help you make that decision. But I wouldn't worry too much about the technical detail at this point. The key takeaway is that there are different types of databases out there, and each one has its own strengths and weaknesses.
So it's about choosing the right tool for the job.
Exactly. Just like with any other tool, you want to make sure you're using the right database for your particular needs. So, where do we go from here? What does the future hold for data science?
Yeah, what's next? It feels like things are moving so quickly.
They really are. One of the biggest trends right now is the rise of artificial intelligence and machine learning.
AI.
You hear about it everywhere, and for good reason. AI and machine learning are transforming the way we analyze data and extract insights.
So it's like data science on steroids.
In a way, yes. AI algorithms can process massive amounts of data and identify patterns that would be impossible for humans to spot.
And what does that mean for the future of data science jobs? Are robots going to replace data scientists?
That's a question a lot of people are asking, and the answer is not so simple. It's more likely that AI will augment the work of data scientists, not replace them entirely.
Okay, so it's like a collaboration.
Exactly. AI can handle the heavy lifting, the repetitive tasks, freeing up data scientists to focus on the more creative and strategic aspects of their work.
So more like a partnership.
Yeah, think of it like having a super smart assistant who can do all the number crunching for you while you focus on the big picture.
That sounds pretty amazing. But are there any potential downsides to all of this AI integration?
There are always risks and challenges with any new technology. One concern with AI is the potential for bias. AI algorithms are trained on data, And if that data reflects existing biases in society, those biases can be amplified in the results.
So it's like garbage in, garbage out.
Exactly. It's crucial for data scientists to be aware of these biases and to take steps to mitigate them. That's why ethical considerations are becoming increasingly important in the field of data science.
It's like the Spider-Man quote, with great power comes great responsibility.
Exactly. Data scientists have a responsibility to use their skills for good, to make sure that the insights they generate are accurate and fair and unbiased.
So it's not just about the technical stuff, it's about the human element too.
Absolutely. Data science is a powerful tool, but it's up to us to use it wisely and ethically.
Okay, so as we wrap up this deep dive, any final thoughts you'd like to leave our listeners with? Anything they should keep in mind as they continue exploring the world of data?
Sure. First of all, I want to emphasize that data science is a constantly evolving field. What we've talked about today is just the tip of the iceberg. There are so many exciting developments happening all the time, new tools, new techniques, new applications.
So it's a journey, not a destination.
Exactly. And that's what makes it so exciting. There's always something new to learn, new challenges to tackle.
So don't be afraid to dive in and get your hands dirty.
That's right. There are tons of resources available online, courses, tutorials, communities. It's easier than ever to get started with data science.
And you don't need to be a math whiz or a coding genius to do it.
And not at all. Data science is for everyone. Whether you're a student, a professional, or just someone who's curious about the world, there's a place for you in this field.
And who knows, you might even discover your new passion.
That's the beauty of data science. It's a field that's full of possibilities. You can use your skills to make a real difference in the world, to solve problems, to create new innovations, to help people.
All right, on that note, we're going to wrap up this episode of The Deep Dive. We hope you enjoyed this exploration of data science and big data, and we hope you'll join us again next time for another deep dive into a fascinating topic.